Hello, everyone. You all look so lovely that I want to get a selfie with you. Smile. There we go. So I want to start with a horror story. It's a very short horror story. In fact, it's only one sentence, and it comes from a Wikipedia entry on the same origin policy. And it goes like this. The concept of the same origin policy was introduced by Netscape Navigator in 1995. Some of you know what's coming next. Shortly after the introduction of JavaScript in Netscape 2. So for those of you that don't understand why there's laughter here, it's a horror story because the mechanism the web uses to prevent information from leaking between origins came after JavaScript allowed you to leak information between origins. And it's a familiar horror story, right? Because, hands up if you haven't worked on a product where something was implemented before you understood the security implications. There are no hands up for those of you that aren't looking around. Okay. But despite being a horror story, it's a starting point that can give us some hope. Why is that? Because web browsers have come a really, really long way since 1995. Now, to illustrate this, I want to imagine that you're given the task that a browser engineer has been given. The product doesn't exist yet, but you've got to write an application in C and C++. The input data is non-trivial, and it's going to be loaded across the internet from origins that you don't trust. And it can execute arbitrary code by design. And it supports all kinds of media. There are images, there are fonts, there's video, there's sound. It can render 3D scenes. And you've got all of these different security contexts, and they have to be mutually exclusive. They're not allowed to influence each other. They're not allowed to observe each other. And by the way, it handles your users' most sensitive data, right? There's healthcare information in there. There's financial information. There's really intimate stuff. And you've got to build that product, and you've got to build it securely. And that's a really, really daunting task. And I think that a lot of the people who were working in browser engineering back in 1995 had no idea what they were letting us all in for, or maybe they wouldn't have done it. But despite these challenges, despite this long and daunting journey from a pretty horrific start, browsers are incredibly safe today. Who uses a browser for something really, really important? Yeah, that's every hand up in the room, right? And it's not only that they have come to a place where things are really secure, they've helped us solve a load of security problems along the way as well. If you've ever used SSL or TLS, if you've ever used a bug bounty program, if you've ever used sandboxing on a commodity device, if you've ever used a safe systems language, if you've ever used WASM, the list goes on and on and on and on. These are all things that came out of our web browsers and the companies who built them, right? So yeah, browsers have come a really, really long way since 1995, and there are loads of lessons on that journey that we can learn to help us build our systems more securely. And so what we're going to do over the next few minutes is we're going to pick two of those lessons and take a look at them. So the first lesson is in choosing our boundaries. And this is a sort of really high-level sort of architecture thing. There's this common error that people make when they're thinking about the security of a product to confuse the presence of a security technology with the security of the product itself. You've probably all seen websites that say, this site is secured by such and such a certificate. And you're like, really? And sure, you often need security features to make your product secure, but the security comes not from the feature, but in how that feature is used. And with that in mind, I want to talk about the sandboxed web browser. Think about modern Chrome, modern Firefox, that sort of thing. Sandboxing tech is absolutely amazing. It's, I think, the biggest security achievement in browser development history. And I'm not going to go into the details of how they work. Suffice it to say, it's a boundary that you can put your stuff in so that when it executes, its capabilities are limited, right? But the really important lesson about browser sandboxing is not how cool the sandbox is, although it's really cool, it's in where you have to put it. Okay. What do I mean by that? Well, there's this thing in the Chromium security documentation called the rule of two. And the idea is that you take this Venn diagram you've got here with its three circles, untrustworthy inputs, unsafe code, and high privilege. And as long as you're only dealing with one or at most two of those things, you're fine. But the thing is that your browser is written in C and C++, so one of them is a given. And the middle of that, well, that's kind of what browsers do. So what do we do about this? How can we deal with it?
Hope you're enjoying this video, but did you know LeadDev has lots more to offer?
So webinar, podcasts, I even like articles, conferences, events, and most importantly, community.
And even thinking about like process, tech, and people, which is how LeadDev website is laid out, I really think this is the #1 learning platform for me as an engineering manager.
Don't forget to check out leaddev.com.
And so what the browser does, and this is the same regardless of which browser you're using, is to split the bits that you need to worry about from the bits that you're trying to protect. You take your high privilege, all of your sensitive data, all of your passwords, all of your access to underlying system stuff. You take your untrustworthy inputs and all the parsing and stuff, and you keep them as far away as possible. And then you've got a natural place to put your boundaries, and then you can come up with ways of allowing those things to communicate with each other in such a way that you no longer have things that are untrustworthy, okay? And we can take this idea and we can learn the lesson and apply it in completely different contexts. My slides always feature chickens. We've had elephants. We've had dragons. We've had I can't even say that word. So we've got chickens here. The rule of 2 is about separating the stuff that you care about from the things that could go wrong. And in your system, in your architecture, it might not be about untrustworthy inputs. It might not be about unsafe code. Maybe it's about a legacy system that was built before they thought about the security of something, or maybe it was intended to not be accessed in an interactive way. Or maybe it's a third-party library where you don't know how secure it is. But the key thing here is that you need to take your information assets and remove them from the stuff that you can't trust, and your boundaries go in between. So that's our first lesson. Separate your threats and your assets. Don't mix your threats and assets. Moving on, as senior engineers, our main job is not about actual technology. Sure, we're good at that. That's how we got here, and we need to understand the tech that we're using, but our main job is about communicating. It's about communicating what it is that we're doing. It's about communicating how we're going to do it and why we're going to do it in that way. And often, engineers complain about some aspect of the thing that they're working on. Maybe it's accumulated technical debt. Maybe it's frustrations with tooling. There are these things that are important to them that aren't deemed important by leaders that don't understand. And there's an important question that's posed by this. If these things are so important, why is it that they're not understood? And the answer is that there's no inherent advantage in a tidy code base or in using the latest thing or in avoiding technical debt. And if there's a reason why that specific thing is important, it's our job to make sure that that's properly communicated. And I sometimes joke that as a security engineer, some of my best work is done by other people. And our next example illustrates this. It's the example of Rust in Firefox. If sandboxing is the biggest improvement in browser security in history, the second biggest is safe systems languages. And you might naively assume that because it's such a big security improvement, that's the reason it first got there, right? And people did want that to happen. But no, the thing that got Rust into Firefox was a performance problem. They wanted faster layout, so they introduced the Stylo engine. To illustrate how hard it is to do performant parallel code in C++, I've chosen this picture from Mozilla memes, which is that you need to be this tall to write multi-threaded code because it's really, really hard unless you use Rust. Now, what happened here is that they did some work to improve performance, and there was a fantastic side effect. It made the browser a heck of a lot more secure, and there are metrics on the decrease in the number of serious security vulnerabilities as a result of this work. So again, we're not building browsers. What can we learn from this? And it's to align incentives. You want that sort of thing to happen in the development of your product, and you want to make sure it doesn't happen by accident. Find places where security goals align with other goals and build a culture that encourages the identification and exploitation of those. For example, are your software engineering teams struggling with inflexible code and technical debt? Are your security people struggling with dependency vulnerability management? Well, these things have got the same root cause, right? And the same fix. You know, focus on the technical debt that hurts agility, and you've solved the problem for both sets of people. So what have we learned? We've learned to think about boundaries, not just how to enforce them, but where they are and whether that makes sense. And we've learned that security is a hard sell on its own, and that part of our job as senior technologists is to find opportunities in the priorities of other people. And most importantly, we've learned that progress is possible. We started out with a horror story in one sentence, a daunting journey that maybe people wouldn't have undertaken if they'd understood, but we're now in a place where browsers are incredibly secure. And if browser vendors can do that, well, so can you. So that's all I had to say. Thank you very much for your time.